Welcome, Rawlinson. My name's Kristen Patterson, and I'll be moderating the defense proceedings today. Your VCDX panel is made up of 3 members, John, Mahesh, and Ben. Please direct your remarks to the panelists, not to me or the observers. We have 75 minutes for this section. The timer will start now. Please begin the presentation you have prepared.
Thank you. Hi, my name is Rawlinson Rivera. I am a consultant architect at VMware. I'm going to present a design for a customer based on a vSphere 4 infrastructure environment. First, I'd like to go over the overview process on the things we're going to cover. Later, I will explain also the architecture design methodology that I applied for the decisions in my design and my process of how to derive to every single decision within this design. Then we'll get into the conceptual design, and I'll discuss after that the design details, which basically covers all the technology-based and driven decisions as well as configuration specs within the design. So what are we trying to accomplish? So we have a company here that was composed of a couple of environments they already had in place. The goal was basically to try and to move a legacy infrastructure from a 3.0, 3.5 vSphere environment, which was composed of about 800 virtual machines. And they were in different execution zones. They were used for about, what you see here, 245 for production, 335 non-productions. There was a certain amount of VDI environments, and also in total, they were expected to have about 194 extra systems to come into this now infrastructure we're going to lay out. So we have to build, have available resources with what we have available at this point in time. There were some very specific goals in the design. The goals were to pursue an initiative to optimize the infrastructure, and bring in the new VMware vSphere 4 environment, consolidate the existing environments into a cohesive infrastructure so that I no longer would have multiple in different versions. I want to have a unified infrastructure as well. We want to maintain compliance in terms of the service level agreements. We get into some of the details of that. As some of the workloads here, some of the virtual machines have a specific set of requirements which are in terms of performance. And how do we also improve the infrastructure in terms of efficiency and reduce the costs? So there's some very specific things that we have to cover for this design. So I want to take you quickly through my process, the method I use and how I derive to this sort of design. So I take somewhat of an unconventional approach where we have a conceptual, logical, and physical design. In this case, I laid out in the form of a pyramid, being the fact that the conceptual area is where it took me the most time to gather the requirements and gather all the information that I need in order to come to some sort of solution, even to the logical layer, right? In the logical layer, I was able to define and gather all the requirements from the customers, which will then lead me to the one piece, which is at the point the physical part of the design, which is now at this point, plug it in the nuts and bolts at that point, right? We want to make all the configuration changes. We have the hardware defined and all that stuff in place. On top of that, the VMware architecture, from what we've gathered from the application, covers certain design principles, right? So we have to be able to somehow balance all these decisions and all these requirements and balance them in a way that we can derive to the best solution possible or the best decision possible, keeping in mind some of the design principles. The design principles for VMware are based on availability, manageability, recoverability, performance, and security in no particular order. But in this case, they were laid out in this way. So my point is that I want to make sure that I illustrate the fact that every decision made into this design, from the logical, conceptual, and physical, was weighed against these qualities, right? So the conceptual design was based on this one single data center. It was based in Phoenix. We have X amount of hosts that were allocated to the project. There's a certain type of the network infrastructure they have in place. It's one network with future expectations of scaling out the infrastructure to multiple buildings. But as of right now, we're focused on one building and one place at this point in time. There is shared storage, so the customer actually has an existing storage infrastructure in place that we'll utilize that again and repurpose it as we bring in the new vSphere 4 environment. From the compute side, so there's a set of execution zones, and what I mean by execution zones, you'll see that they have isolated environments that they maintain and manage separately. So one is what they call the production environment. They have a non-production environment and also the VDI. In this sense, we present them as clusters because it will be the compute resources where each one of these environments will reside. They have their own dedicated hardware, and it was laid out as such. Their network infrastructure in terms of speed has a mix. There's a 10 gig Ethernet environment for their IP network, but also there's a fiber channel environment for the storage, which consists of 8 gig fiber channel network as well. So when we get to now the compute design, taking into account some of the requirements in the hardware that was made available to this project, some of the decisions that were derived to this design were based on customer requirements. There was also based on best way to kind of use these components in the best possible way where it would be not only functional, it would decrease the manageability, reduce the risks, but also keep in mind that we want to reduce the cost. We want to make, use whatever we have available because we could increase upon that. So in this case, the physical hardware was composed of HP Blade 7000 series, with each one of these chassis would take up to 60 nodes within the chassis. So we had a total of about 27 blades only available. We couldn't go beyond that point. They were all based on the same Intel platform, the same speed. Each one of them, the memories, was set up to 96 gigs, which is really important in terms of how are we going to provide and design the consolidation ratio per environment in this case, being with the fact that we're pretty limited to those and constrained by those requirements. I labeled the different layouts as in production, non-production, and VDI. So we have 4 chassis in this environment. In this case, right now at this time, with the hardware we have available, one cluster, one 8-node cluster, will suffice enough to sustain what is currently within that infrastructure, but also will allow for room to grow. Remember that we have a list of about 194 virtual machines that we need to, later on, are going to be P2B, that need to be able to be supported by this infrastructure. Now, the way of the layout of the cluster is done in this way because of, number one, the customer has somewhat of an old school approach, an old school mentality to say into this design. They still believe in the one isolation and moving things apart so that they can address their availability requirements in that way. But and after much debate, this is what the customer signed off on, right? So here we have a 8-node cluster for each one of those execution zones, and they are kind of spread out. The way they're spread out in this case, for lack of a better term, if it serves the purpose of dissipation of heat within the chassis, you kind of want to take that into consideration. In one entire chassis just sits there idle in the event of a failure. Their way of addressing a failure of a chassis, which in this case is highly unlikely, right? So I did the research and looking into the time of life, the expanded time of life that HP puts on these chassis is, I think it's over 100 years, right? So when you think about mitigating failures into a chassis for this configuration, it's highly unlikely, one, but to take into consideration the fact that if that ever were to happen, it addresses the failure on the fault domain for the actual cluster. Because we have a single an 8-node cluster here, we don't have to worry about failing over to another chassis because the nodes are within the same chassis as well.